So, metrics that matter. Um, the remit for this talk was basically, all right, fine, you're in charge of oh, I should introduce myself. So my name is Ben, and if Google ever stops working, it's my fault. Um, Forgot that part. We did the intro in the last session, and I was running with that. More concretely, I created the site reliability team at Google, and still run it. I also run all of networking for Google and all of data centers for Google, from design and construction to operation. So it's a low-stress job, regular hours. And it teaches you a thing or two about scale. And my background is software engineering, so this is sort of the first operationally oriented gig I've done in my entire career. It's been an interesting learning experience. But I have learned a few things about scale. And one of the things that I've seen is sort of the pattern over and over again of the same small number of metrics show up time after time in operating and measuring and assessing software services that are running at a decent sized scale. And so rather than sort of having a generic talk about metrics and why they're important and blah, 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 you already know that, right? Skip all that. Let me tell you the three that I've seen over and over again actually are really important if you want to have a great user experience at the end of the day and you don't want to have your service collapse under its own weight. So, been doing this since 2003. Back then, we still had a cloud product. We didn't call it cloud at the time. We called it Borg, but it was all of the things that you're now familiar with in the public cloud offering, right? We had services. They run in containers. You have these relatively homogeneous and entirely fungible compute platforms that you run it on, and jobs can move around, and things can die, and blah, 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 blah. And it was a good way to run search, and it turned out to be a good way to run Gmail, and we've kind of run with it. And now, of course, it's something that we're offering to everyone, and the term cloud has picked up. But we've been doing this for a while, and in particular, when I went back and looked at kind of the scale of what Google's been doing, we've been through 7 orders of magnitude so far, and still growing. So who knows? In a couple of years, this presentation may read differently. But we have managed over that time to evolve some best practices about sort of how you run things and also how you measure things. We're going to skip the how you run things for a separate topic. This is just about measuring. And again, I want to note, this is not everything that's important to measure. These are the things that I've found really are both critical and often not actually measured because they're not easy to measure. But in retrospect, after the bad user experience or after the outage or whatever, you sort of go back and say, wow, if only we had. This is the if only we had list. So item number 1, measure your actual user experience. Seems straightforward, right? I mean, you've all put your time and effort and sweat equity into building this service. And you test it yourself. If you're pretty much like everybody out there, your development team uses your own product, otherwise they wouldn't be working in your company. But you're testing it here or in your development lab, close to your servers, on a really great network with fairly little competition and probably Wi-Fi backup. So newsflash, most of the world does not experience your product the way you are experiencing your product. In fact, statistically speaking, very little of your user base experiences it that way. So rule number 1 that we've come up with is measure the actual user experience, right? Because your users don't care how well it works, on your awesome brand new Pixel, on your Wi-Fi, in your home office with your data center 20 milliseconds away. They care how it works for them. And if it doesn't work well for them, somebody else will build a product that does, right? I know the answer, but hang on, right? But it's hard. I apologize, I'm going to move this thing. It's hard to measure the actual user experience. It's much easier to measure telemetry that's coming back to our servers or to measure, what we see in our test lab. I apologize. Speaking of measuring the actual user experience. It's my first time with a headset, and I think it's not entirely agreeing with me. So, why do most teams not actually measure what their users are experiencing? Well, because, you can't exactly talk your user base into putting a GoPro behind their head every time they're using your product so you can see what's going on. It turned out that has a very low adoption rate. And it's not actually easy to measure, especially, a mobile experience, or in particular a web browser experience. Back when everything was thick client, you could kind of instrument your thick client and you'd have a decent sense of what the user experience was like. But when you have all sorts of other layers of software in between your app and what the user is doing, and then you also have a network and maybe you have a browser, et cetera, it gets much harder. And so as a practical matter, what I see often is that teams approximate this, right? They'll put in some decent server-side monitoring. They may even have a test lab where they get some benchmark results, like how long does a page take to load and so on, but they aren't actually measuring the distribution of what the user experience is because it's difficult. My advice for all of you, yes, it's hard. Get through that denial and go on to actually measuring the thing. And if you have to spend 10% of your engineering team to do it, right? Because that is what your user experience is, and you're spending the other 90% trying to write a software service or a feature or a cool widget, and you have no idea what people actually see when they try to use it, right? So, it's the #1 omission, right? What can I say? Even at Google, right, we pretty regularly run into this. The team presents, here's what they think the service is like, and then you actually go and do tours, for example, and you look, and the experience is totally different. We see it over and over again. I see it when I talk to companies that are building products, both on cloud and not on cloud. They really only approximate what the user experience is. And why is this important? Well, let me give you a case study from Google's history. Defense in depth. Very important concept in reliability. We're not going to talk about it today, but you just had it illustrated. So back in 2004, Google launched this service. Some of you may have heard of it. It's called Gmail. It promised at the time a gigabyte of storage. Ooh, right? Back at the time, that was impressive. I think you got 5 megabytes on some of the other popular services. And people's use of it was almost entirely browser-based, right? There was mobile adoption, but it was not the dominant way of accessing Gmail. And so the teams did what pretty much everybody did, which is, well, let's look at what's happening at the server, right? And if we get the HTTP request and we send the response, and it took us, 220 milliseconds on average to serve the response, and we had, an error rate of whatever, 0.007%, life is good. So that went on for a while. We got anecdotal reports of people saying, oh, Gmail is slow and the experience is not really that great, especially if I'm, not connected to really fast, 2 megahertz Wi-Fi, right, et cetera, et cetera. And so eventually we decided to launch a new Gmail client, right? It's JavaScript that actually got downloaded when you started using Gmail, and we decided to instrument the client. And then we had the 5 stages of grief, right? Starting with, as it always does, denial, right? No, this can't possibly be right? There's no way. It's like taking 20 seconds to load the inbox, because when I do it here at Google, right, on my brand new, oh God, at the time, who knows, Intel laptop running Firefox, it's nice and snappy, right? Well, I don't need to spell the rest of it out for you. That is not the normal experience. And in fact, the inbox load times were very, very slow. The mail message load times were very slow. In some cases, the page render times were very slow. You had to get through denial. So after a couple of rounds of making sure the metrics were right and actually doing, sort of tests out in the field, we convinced ourselves, okay, actually, no, this is what the user experience is. Wow, that's pretty crappy. And we got eventually to bargaining, which basically became a whole new set of changes, both, interestingly, changes on the server side, right? Things like delivering incremental updates and delivering sort of real-time feed, and obviously on the client side, where you make rendering changes and you change, you change sort of how the page is presented and so on. You actually might present it differently on a different speed device so that you don't consume too much of your time just trying to literally draw the pixels on the screen. And I remember distinctly, because this was 2006-ish, there was this inflection. Gmail had been growing beautifully, right? It had an up and to the right curve, which I will now illustrate, in the air. And then we launched the new client, and then its curve did that, right? And it was this, you could correlate this change in the adoption curve to us launching the new client and the server updates that were entirely due to having actually measured the user experience and getting through the 5 stages of grief. And it was, I don't know, it was a significant effort. There was a lot of debate at the time about, is this important, and shouldn't we be adding a bunch of new features, and, look at Hotmail and look at Yahoo Mail, and et cetera. But we spent the effort to improve the client and to improve the user experience for people who didn't have the latest laptop and didn't have the really fast Wi-Fi and so on, and it made this enormous difference in actual adoption. So for me, that cemented the lesson for forever, right? Measure the user experience, even though it's painful, even though it's going to take a bunch of big engineering projects, because you will never build your app the same way again, and you will get a much better user adoption as a result of doing it. Much more impactful than any feature that we could have launched. And yes, it's hard, right? So the engineering team will also have to go through the 5 stages of grief in dealing with the fact that in addition to writing all the features, they also need to write the things that let you measure what the users are seeing. But persist. Metric number 2, tail latency. All right. Sounds incredibly boring, unless you're in reliability, in which case, we live for this stuff. But let's run with boring for right now, right? So quick survey of the room. Hands up if you think roughly you know how reliable your service is. See, I gave way too much away. Like, the only people who are raising their hands are the ones who clearly do not know. because they're in my team and they already know what this drill is, right? So yes, we just talked about the importance of actually measuring the user experience the way the users experience it. But if you do that, then clearly you know how often the user gets an error, and therefore you know how often your user considers your service to be available. If that describes you and your perspective on your service right now, this will come as something of a disappointment, right? So users typically treat a sufficiently slow response as the same thing as an error, and they'll do one of two things. They'll hit refresh if they're kind and think that otherwise highly of your app, or they'll switch to a different app and maybe they'll come back to yours. But certainly they won't have a good experience, and it will be the same for them as if they had gotten an error, except the error at least is sort of a polite prompt that says you should hit refresh, whereas no answer is impolite and tells you to waste your time. And so I think of availability as being the above formula, right? Availability is 100% minus all of the errors that you return, and also minus all of the slow responses you give. And if you picture this for yourself, right? Suppose you use a nice, snappy, modern web-based application or mobile-based application. We offer a few of them ourselves. And on average, you sort of make a query, and within half a second, the thing responds and actually gives you the answer or does the transition or whatever. Fine, that's great, right? So suppose 1 time in 30, whatever it was that it was doing to process that, fails somewhere internally in your stack. And so eventually, your timeouts kick in, and you assume you retry the query for them as opposed to making them hit refresh, because that's barbaric. So you refresh after 10 seconds, and it retries. Okay. So your availability metrics there, right, will say that it's 99.9 something available, because that's how many errors you're serving. Your users will say it's about 97% available, which is, for a mobile app, not terrible, but it's not great, right? Most of the mobile apps that I use are probably on the order of 99% available, and I can definitely notice as a user the difference between, let's say, 99.5 and 97, which is what I have here. You'd have a completely different view of what the user experience is just by changing the way that you consider availability. And so then the question, of course, becomes, well, how much slower than median does the thing have to be before the user will consider it to be an error? I don't have a generic answer for you, because it depends a lot on your app, right? If you're using an app like Mail, and it takes a few extra seconds for a mail to be received, you don't even notice. Right? If it takes a few extra seconds for you to hit send before the mail is registered as being sent, you notice that, right? And if you click on a mail and the mail doesn't snap up instantly, you're going to retry it yourself in a couple of seconds, so maybe factor of 4. But you can probably see this, and if you can't, you should figure it out, right? Again, back to measuring the user experience, because you want to know at what point your user thinks your app isn't working correctly. And if you don't know that, well, your users do, and you won't change your app appropriately, and then you'll have less adoption and eventually catastrophe. So if you want a rule of thumb, right, something to walk away with, 5x. 5x is a pretty good rule of thumb for many interactive applications that I see people using. And it's not complicated at that point, right? You can measure what your median latency is. Just consider anything that's more than 5 times as slow as your median latency to be an error. And, again, 5 stages of grief, right? Followed by, then you'll actually spend some time and try to figure out, really, is it 5x or is it more like 8x, right? I encourage you not to be overly optimistic, because, again, eventually the users will make their own choice about your application. You'd really like to know what they're seeing and how they're behaving, and you'd like to have the opportunity to tune your app to deal with that. But figure out what latency starts to cause people to retry or starts to cause them to switch off your app and do something different for a while and come back, and tune yourself so that your tail latency is below that, and tune your metrics so that once you hit that tail latency that causes them to switch behavior, you consider it an error, and then you can decide how available you want your app to be, right? But that is actually measuring the user's experience of availability and not your server's experience of availability. And if you haven't measured this sort of tail latency before, like I said, just 5 stages of grief, let it happen, right? You'll get through it, but don't stay in denial. So topic number 3 then is service efficiency. And this could mean a lot of different things, but it is the place that I see the most applications get tripped up on, so I wanted to spend a bit of time talking about it. So let's talk about capacity planning, right? It is as boring and dry a topic as you could possibly imagine for most developers. Pretty much almost all developers, I think, unless you're actually charged with making sure the app works, in which case it is near and dear to your heart, right? So capacity planning is essentially a simple thing. You take demand, right, which you typically get from historical behavior, you extrapolate it forward through time, you add in anything that we call inorganic, but basically if you're going to change your application to make the demand go up, or issue 2 queries instead of 1, or whatever you're going to do that changes your demand curve that you know is going to happen, you add it in there. You divide that by how many servers it takes to actually answer a query, and there again, you can change the server and blah, 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 but it's probably been fairly constant over time. So you divide that, and that tells you how many servers you need, or how many instances you need, or if you happen to be stuck on a cloud product that makes you buy stuff in advance to get a good price, how many you're going to have to purchase, and you're done, right? Easy peasy. Well, say no, unfortunately, because there is this extra bit, which is that you're all either developers in this room or you manage developers for the most part. All of you are doing things to that binary that's running on those servers, and you're doing things that change the amount of time that is required for processing a given query, right? And so even if you are perfect at extrapolating how many queries you're going to be getting, you're changing the, if you will, the denominator, and sometimes you're not changing it by a little bit, right? It was not uncommon for us to see swings of 50% over the course of a week. If you're not watching it, because it's easy to sort of add things to the inner loop, and it's easy to add a feature that makes a call out to something else, and blah, blah, blah. And even small changes like configuration file changes can sometimes dramatically change the amount of compute capacity that's required to process a query. And we call that service efficiency overall, right? How many CPU cycles, disk spindle seeks, network bytes, et cetera, is required to answer a query or to serve an interesting action in your service. And like I said, easy to change, basically invisible, right, unless you do performance testing all the time, which we'll get to in a second. And one of the most frequent flyers in the postmortem that follows, inevitably, from this, right? Because, of course, what happens with service efficiency is none of you, presumably, run your services at the very hairy edge of falling over all the time, right? Everyone builds redundancy into how they do provisioning. Either it's redundancy to handle peaks that happen to happen, right? You're running a news service and something interesting happens in the world. You can use your own imagination as to what that might be. And demand spikes 30%. Or you're running a photo application and there's a concert, and so within this one area, within this one geographic region, suddenly the number of pictures people are taking, no, you don't even need that, right? Just wait for New Year's Eve. And the number of pictures that get taken on these hourly spikes, it's very odd, right? Goes way up. So you have enough redundancy to handle spikes and also to handle a certain amount of failure, right? Service efficiency changes eat into that capacity reserve that you've got, but they do it invisibly, because normally you're provisioned to have a bit of failure, and if you don't have a bit of failure happening at the same time you have a spike, everything runs great, right? And so the postmortem usually reads something like, we thought we were provisioned N+2 for peak, but it turned out that over the past 2 weeks our service efficiency had gone down because reasons, right? Which could be like we introduced a new CPU type that we were using, or somebody checked something in. Like the list of reasons is always different. The result is always the same, right? So it turned out we were actually provisioned only N+5, and then one of our sites had an outage, and then cascade failure, right? Because once you're out of capacity, unless you've done a very careful job of designing a distributed service to do very good load shedding, right? cascade failure all the way through, and then the only way to recover from that is basically shut off all the traffic and then bleed a little bit back in to get the caches warmed back up, and eventually you can get back to a stable operating model, but it takes hours, and your users notice. Ask me how I know this. So, the best practice here is, again, sorry for creating more work, but this is really important. You got to measure how efficient your service actually is at servicing queries, and I don't actually think that daily is too frequently. Right? The best practice, of course, would be, well, build a system that actually measures it for me and spits out a report every night, and then I'll notice immediately. It's much easier to automate this sort of thing and have a performance test. And you don't have to test every little edge case, right? You just have to test the things that are the big volume drivers for your service. But if you have it automated and you get this report every night, you'll notice. You'll also notice other interesting things like, hey, you know, our service efficiency is still the same, but our latency's been creeping up a few milliseconds every week. Right? And so we've gone from having a service that was nice and snappy to a service that's kind of kludgy even on a good device and really bad on a bad device over the course of 3 months without anything dramatic happening, right? And that's obviously something else that can bite you. It bites you mostly in that your user adoption seems to nose over a bit more than you would have hoped. You know, if you're running hypothetically on a cloud provider that just has flexible use, and so you can sort of use more capacity, you might not have a cascade failure when your service efficiency gets bad, but what will happen is your finance person will come and find you a few weeks later, and they'll say, you know, we got a bill from our cloud provider, and it's about 30% higher than we had expected. What's going on, right? And then I would say typically 2 or 3 weeks of thrashing goes on. You accuse the cloud provider of overbilling you. The cloud provider, you know, does their own diagnostic and says seems to be running normally. This is assuming you have a cloud provider who lets you flex in and out, right? If you have one where you're running on fixed instances, then your service just goes down, which has the upside of no extra bill and you know, sort of prompt diagnosis. So I guess, you know, there's pros and cons to each side. Personally, I'd rather have the finance team yelling at me than the sales team, but you know, that's me, right? So to keep your costs under control, but more importantly, to keep your service stable, you've got to know what your service efficiency is. And the way to know that, because developers will check stuff in, that's what you pay them for, right? The way to know that is to actually benchmark it quite regularly. So that's actually it. Like, if I trace most of the big postmortems where things that were not sort of obvious were happening, I could put them into one of those 3 categories. And so if you measure those 3 metrics, and go through the work that it's going to take to actually measure them accurately, not as an approximation, I think you will find that A, your service runs better, B, you have fewer outages, and C, you have a lot more user adoption. And you know, most of us kind of like those 3 properties. So that is it.